All right, we're going to do some more practice verifying trig identities. The first thing that we're going to do is fill out this box of things to try. So the first thing I'm going to say when you are simplifying is substitute some of the identities. Substitute the identities. So I guess the question is, what are those identities? All right, the first one that comes to mind is sine squared of x plus cosine squared of x. And what does that equal? 1. Okay, and just for practice, if we ever see it rearranged, for example, what if it said cosine squared? What would you replace instead of that? That would be 1, then move over, minus the sine squared of x. Okay, good practice. All right, how about the second identity? Number 2. The second identity, if I divide him by sine squared, what does that make? 1. Divide cosine squared by sine squared, that's cotangent squared of x. And divide him by sine squared, that gives you cosecant squared of x. And what if I was doing a problem and it said something like 1 minus cosecant squared of x? What would you replace that with? If the cosecant squared was on the left, that would make negative cotangent squared of x. We have to be careful with the negatives with the identities. And finally, let's go back to our original one. This time divide by cosine squared. That makes tangent squared of x. Divide by cosine squared, that gives you 1. Divide by cosine squared, that makes secant squared of x. And what if you were doing a problem and it said something like secant squared of x minus tangent squared of x? What could you replace instead of that? That would be a 1. Okay, so that's one idea, substituting with identities. What else is a good idea? Okay, something else you could think of? Think about factoring. Factoring is always nice. That might simplify some things. What if there's a bunch of fractions? We could proceed by making a common denominator. That's something you could try. Okay, but only if there's fractions, of course. Very, very popular technique. Change all terms into sines and cosines. What's nice about that is they all can either go together or cancel out. Okay, and then another very, very popular technique. You can multiply by the conjugate. Okay, when you multiply two conjugates together, what does that make? That makes a difference of squares. Difference of squares. And you know what's so nice about difference of squared things? Is you got those identities right there. So these are very popular techniques, things that are good to try. And of course, okay, the best technique, triple star this one, don't be a quitter. Yep, that is an actual technique. Okay, so if you try something and it doesn't work, you don't get to say, I couldn't get it. You have to try, and bring in 5 pieces of paper and say, now I really can get it. Okay, all right, here's our first one. It says to simplify, so we don't have a left-hand side, right-hand side. I'm just going to write the problem. And I'm looking at this, and holy cow, there's a lot of signs. I can't combine them, and there's no squared sign, so I can't use identities. There's no fractions. Maybe I'll factor. What should we factor out? How about just one sign, sine of x? Okay. Make sure that when you divide sine by sine, you get a 1. Okay. When you distribute it back in, does that make sense? Sine of x, and then here is going to be sine squared of x. Okay. The biggest question that I get is, how do I know if I'm done? Well, sometimes you have to try some more things. If trying things can make it smaller, then you definitely should do it. Is there any way to replace sine squared. Let's go back up to that identity. Ooh, 1 minus sine squared can be replaced with cosine squared. Ooh, let's do that then. So is having two terms more simple, or is having one term more simple? And one term is obviously more simple. And that means we are done. Okay? Being done is hard to tell sometimes, so I'll try to walk you through that a little bit. Okay, here's another simplify. No squareds, nothing the same. I can't factor. Maybe we should change all of them. Maybe we should use the technique where we change everyone into sine and cosine. Okay, let's do that. So I've got sine of x. And this is times tangent. So that's going to be times tangent. But instead of tangent, let's write sine of x over cosine of x. Okay, minus sign. You have to write the whole problem, every line. Instead of saying secant, let's say 1 over cosine of x. Now this is multiply. This is multiply. In fact, that's like sine over 1. Can you just continue this divide bar? Yes. Yes, you can. Okay, so the numerator, you don't cross. That's if there's an equal sign. So this is actually, common denominators. Let's write one denominator, cosine of x, and what's the numerator here? Sine squared of x minus 1. Okay, are we done? I don't think so, because I see sine squared and I see a 1, so please go look at the identities and tell me what I should replace that numerator with. Did you say cosine squared? Okay, if you said cosine squared of x, you're wrong. It's got to be a negative. It's got to be negative. What? Sine squared minus 1. If we bring the 1 to the left, sine squared minus 1. Yes, we'd have to bring cosine to the right. Okay, so it's going to be a negative. Are we done? I hope you said no, we're not done. There's 2 cosines on top and 1 on the bottom. So we can go ahead and cancel a cosine with a cosine. So how many cosines are left up there? Just negative cosine of x. In fact, that's exactly how I'll leave the answer. Okay, so I can tell now that we're finished. There's really not much more to do with the cosine. All right, any ideas on how to simplify this guy? And the answer to this one is factoring. It's not so obvious to everyone in the beginning. So if I wrote this with a's, remember there's that technique where you make something complicated look really simple by calling it an a. I'm going to let cosine squared be a squared. And then it says plus 2 cosine. So that's plus 2a plus 1. If you saw a quadratic like that, would you be able to factor it? I sure hope so. A and a plus 1 plus 1. Okay, so sometimes writing it down with a's helps people because now they know what to write here, but it's not a's, it's cosines. Okay, so I know that I have to factor. Cosine squared is cosine of x times cosine of x, because a represented cosine of x. The rest of this is going to be plus 1, which means there's 2 identical quantities. Let's just write it together. Say cosine of x plus 1 quantity squared. And I think that's about all we can do with that. Since it's not cosine squared, you can't do an identity. In fact, even if I did an identity and took cosine squared out, do you think putting sine squared by cosines, that'd be kind of messy. At least here it's all the same trig function. So sometimes it's a good idea to see if the functions are all the same and kind of get them that way. Okay. establishing the identities, that means show that it's true. It could say establish or it could say verify. And what that means is you must show the steps. The answer is right there. Okay, so should we pick the left-hand side or the right-hand side? Remember, you want to pick the more complicated side, so we're going to pick the left-hand side. And let's go ahead and write that left-hand side down. Okay, this chapter is not for the lazy or the faint of heart. You must go, go, go. All right, so right here, hey, these things look really cool. Do you know what these things are called, where one has a minus and one has a plus? Those are conjugates. Conjugates. Do you know what's so cool about conjugates? The cool thing is when you multiply them. If you multiply first, cosecant squared of theta, the outers and the inners cancel, and the lasts are minus 1. What's that called? What's that called? Something squared minus something squared. That's a difference of squares right there. A difference of squares. That's what that is. Okay, now we're not done. I see something squared. Can you go back to the identities and see if we could rearrange it all to get cosecant squared minus a 1? That's squared minus a 1. If the 1 went on that side, that would give us cotangent squared. Cotangent squared of the angle for this problem is called theta. Do you think we're done? Yes, we have it down to one single term. We are done. Okay, this last one right here. Let's work. I guess we can pick. Let's pick the left-hand side. Okay, now there's no right or wrong answer to that. They both seem pretty complicated. I guess it depends on what you see. When I look at this one here, I'm thinking I can write him as a fraction and him as a fraction. I got some ideas of where to go. Here, maybe we could work with conjugates a little bit. All right, let's start with the left-hand side. Both ways are actually pretty similar in terms of number of steps. Okay, so I was saying something about write cosecant as 1 over sine of u. And cotangent is cosine of u. Okay, and I like that built-in common denominator. Go ahead and write cosine of u over sine of u. Okay, let's take a peek. This is the answer that I need. I need to get 1 plus cosine in the bottom. 1 plus cosine. Well, I guess I could just multiply the bottom by that. But if you multiply the bottom by that, you're going to have to multiply the top by that. 1 plus cosine of u. Ooh, that might not be a bad idea. Sometimes, instead of simplifying, you're going to find yourself complicating things. And then you know that it's not the fastest way. You might get there eventually, but at that point, you're going to want to abort and start fresh. Okay, but I still see some ideas, so we're going to keep going this way. The numerator, I'm definitely going to multiply. Should I distribute the denominator? Because I see part of the answer that I want. So I'm going to wait with distributing that because I don't think I want to mess that up. I want to keep that just as it is. But the numerator, I definitely want to multiply those conjugates together. So don't multiply stuff until you see a need for it. 1 minus cosine squared of u. Okay, I'm going to go over here. And why don't you go take a peek at your identities to see if there's a way of replacing 1 minus cosine squared. Is that going to be positive or negative? It's going to be positive sine squared of u. And the denominator is sine of u times 1 plus cosine of u. Okay, take a peek at that answer again. Is there a way to make this? In the beginning of problems, you're going to get very excited when you're one step away. Oh, I see it. As you get more experience, you're going to start to see the answer 2 steps away or 3 steps away. So the more you practice, the more experience, the better you're going to be with these things. Let's cancel one sign and one sign, and that gives us sine of u divided by the quantity 1 plus cosine of u. You did it! You turned the left into the right. Oh, I can't wait to see you tomorrow so we can get some more experience.